Hello everyone, a very warm welcome to ABC Trainings. Thank you for joining today's webinar. Today we will explore how data science is used in real world companies from raw data to intelligent business decisions. Today's session is about learning data science and using data science in a real companies. So let's start. Now that we have started the session, let me give you a quick overview of what we are going to understand today. First one is what data science means in real companies. First, we will understand what data science actually means in real companies. Many times when we learn data science, we focus only on Python, machine learning, or algorithms. But in companies, data science is not just about writing code or building models. In real organizations, data science means solving a business problem using data. For example, increasing sales, reducing customer churn, detecting fraud, improving customer experience. So, when companies hire data science professionals, they are not asking, do you know this algorithm? They are asking, can you use data to help the business make better decisions? This mindset difference is very important and we will keep this in mind throughout the session. So, second one is how business use data. The second thing we will talk about is how businesses actually use data. Today, companies generate massive amounts of data from websites, mobile apps, payments, customer interactions, sensors, and systems. Businesses use this data to understand customer behavior, predict future outcomes, automate decisions, reduce risk and losses. For example, when a bank blocks a suspicious transaction or when an app recommends a product, these are all data driven decisions. Data science helps convert raw, unorganized data into meaningful insights that businesses can act on. Then, third one is tools, workflows, and careers. Next, we will discuss tools, workflows, and career roles in data science. You might have heard names like Python, SQL, Power BI, machine learning, and cloud platforms. But the real question is how are these tools used together in companies? We will look at the step by step data science workflow followed in an industry, which tools are used at each stage, then how different roles like data analyst, data scientist, and machine learning engineer fit into this process. This will help you understand where you belong and what skills you should focus on. Then fourth one is industry use cases. Finally, we will explore industry use cases. Instead of just theory, we will see how data science is used in Netflix and Amazon, banking and finance, healthcare, and e-commerce and manufacturing. These real-world examples will help you clearly see how data science moves from data to real business decisions. Sorry. By the end of these use cases, you will be able to connect what you are learning today with what companies are actually doing in a real life. So, this is the roadmap for today's session. Now, let's begin with the first topic what data science really means in real world companies. So, let's start. Now, let's begin with the first topic what data science really means in real world companies. In very simple words, data science helps companies use data instead of guesswork. Earlier, many business decisions were based on experience or assumptions. Today, today companies rely on data to support every major decision. So, first one is a make data driven decisions. First, data science helps companies make data driven decisions. Instead of asking what do you think will work, companies ask what does the data say? For example, which product should we launch? Which customer segment should we target? Which marketing campaign is performing better? So, data science analyzes past and current data to give evidence based answers, reducing risk and improving accuracy. Then, second one is a predict outcomes. The second major use of data science is prediction. Companies don't just want to know what happened in the past, they want to know what is likely to happen next. Examples include: will a customer leave the platform? Will this loan applicant default? How much demand will we have next month? Using machine learning models, companies predict future outcomes and prepare in advance. Then third one is optimize operations. Third, data science helps in optimizing business operations. This means doing things faster, cheaper, and more efficiently. For example, reducing delivery time, managing inventory efficiently, optimizing routes for logistics. By analyzing data, companies identify inefficiencies and improve overall performance. Then fourth one is build intelligent systems. Finally, data science enables companies to build intelligent systems. These systems can recommend products, detect fraud automatically, personalize user experience, support automated decision making. For examples you see every day include Netflix recommendations, then Amazon product suggestions, fraud alert from banks. These systems learn from data and improve over time. So, to summarize this slide, data science helps companies to make smarter decisions, then predict future outcomes, then optimize operations, and build intelligent AI powered systems. This is why data science has become a core function in modern organizations, not just a support role. So now that we understand the purpose, let's move ahead and see how companies actually use data step by step. So now let's understand why data science has become absolutely critical in 2026. Data science is a no longer optional for companies, it is a necessity. Businesses that use data effectively grow faster, operate smarter, and stay ahead of competitors. So first one is a automation and artificial intelligence everywhere. The first reason is that automation and AI are everywhere today. Companies are automating tasks that were earlier done manually: customer support, fraud checks, recommendations, pricing, and even hiring process. For example, banks use AI models to automatically detect fraudulent transactions in seconds. Then e-commerce platforms use AI to manage pricing and inventory. Chatbots handles thousands of customer queries without human intervention. All of this automation is powered by data science models trained on large amounts of data. Without data, automation simply cannot work effectively. Then, second one is a competitive advantage. The second reason is competitive advantage. In 2026, companies that use data intelligently outperform those that don't. Data driven companies understand market trends earlier, then launch better products, respond faster to customer needs. For example, companies like Amazon and Netflix constantly analyze customer behavior to improve recommendations and user experience. This data driven approach gives them a strong advantage and competitors who rely on guesswork. Then third one is a customer personalization. The third important reason is customer personalization. Today's customers expect personalized experiences, not generic ads or recommendations. Data science helps companies to recommend the right product to the right user, send personalized offers, then customize content and user interfaces. Then, for example, Netflix shows different content to different users. Amazon recommends products based on browsing and purchase history. And personalization increase customer satisfaction, engagement, and loyalty. Then fourth one is a risk reduction. The final reason is risk reduction. Every business faces risk, financial loss, fraud, operational failures, or customer churn. Data science helps companies identify and reduce these risks early. For example, banks predicting loan defaults, then insurance companies detecting false claims, business identifying customers likely to leave. By predicting risk in advance, companies can take preventive action and save money. So, to summarize, data science is a critical in 2026 because automation and AI depend on it. It gives companies to competitive edge. It enables personalized customer experiences and it helps reduce business risk. This is why almost every modern company today is investing heavily in data science and artificial intelligence. Now, let's move forward and see how companies actually use data step by step in real world workflows. So, now let's talk about one of the most confusing topics for students and freshers roles in data science teams. Many people think data analyst, data scientist, machine learning engineer, and AI engineer are the same. In reality, each role has a different responsibility, even though they work closely together. So, we see one by one. First one is data analyst, insights and dashboards. Let's start with the data analyst role. A data analyst focuses on understanding past and current data. Their main job is to convert raw data into insights that business teams can easily understand. Data analysts work heavily with SQL for querying data, Excel for Python for analysis, Excel or Python for analysis, Power BI or Tableau for dashboards. For example, creating a sales dashboard for management, analyzing customer behavior trends, then tracking KPIs like revenue, growth, and churn. Data analysts answer questions like what is happening in the business and why. Then second one is data scientist, models and predictions. Next is the data scientist role. A data scientist goes one step ahead of analysis and focuses on prediction and modeling. They use machine learning algorithm to predict customer churn, forecast demand, detect fraud, build recommendation systems. Tools commonly used by data scientists includes Python, Pandas and NumPy, scikit-learn, machine learning models. Data scientist answers questions like what is likely to happen next. So, this all about data scientist. Then third one is machine learning engineer, scalable ML systems. The third role is the machine learning engineer. Once a model is built by a data scientist, it needs to work reliably for millions of users in real time. That is where ML engineers come in. ML engineers focus on deploying ML models, making them scalable and efficient, integrating models with applications, monitoring model performance. They work with Python APIs like Flask or Fast API, then Docker, cloud platforms. cloud platforms. ML engineers answers the questions: how do we make this model work at scale in production? Then fourth one is AI engineer, intelligent products. Finally, we have the AI engineer role. AI engineers work on building intelligent AI powered products. They use deep learning, neural networks, natural language processing, computer vision. For example of AI engineer work include chatbots and virtual assistants, face recognition systems, voice-based applications, AI recommendation engines. AI engineers answers the questions: how can we build smart systems that learn and improve automatically? So, how these roles work together? In real companies, these roles do not work in isolation. A typical workflow looks like this. Data analysts understand and visualizes data. Then data scientists build predictive models. Machine learning engineer deploys and scales those models. And then AI engineer builds intelligent applications on top of them. This teamwork is what powers modern data science systems. So, data science is not a single role, it is a team of specialized roles. Understanding these roles helps you choose the right career path, learn the right skills, prepare better for industry roles. So, this is all about roles in real organization. Then, now let's talk about programming and data handling, which is the backbone of data science and automation. We will focus on Python, SQL, NoSQL, and key Python libraries like Pandas and NumPy. So, Python for automation and analysis. Python is one of the most popular programming languages in data science, and for good reason. It is easy to learn and write because its syntax is simple and readable. Then extremely versatile. We can use it for automation, data analysis, building dashboards, machine learning, and more. Strong community support. You can find libraries for almost anything. For example, you can write Python scripts to automatically process files, fetch data from websites, or even generate reports without manual effort. This is what we mean by automation. Then second one is a SQL for structured data. SQL or structured query language is used to interact with relational databases like MySQL, PostgreSQL, or SQL Server. It helps us store, retrieve, and manipulate structured data that is organized in rows and columns. With SQL, we can perform queries like filtering, aggregating, and joining tables to extract meaningful insights from large datasets. For example, if you have a table of sales records, SQL can quickly calculate total sales per region or find the top selling products. Then third one is a NoSQL, MongoDB for unstructured data. While SQL handles structured data, many modern datasets are unstructured, like JSON files, social media posts, or sensor data. NoSQL database like MongoDB allow us to store this data in a flexible format without predefined schemas. They are perfect for big data applications where data can be dynamic or rapidly changing. With MongoDB, you can query complex data structures, store large amounts of data, and scale easily. Then fourth one is Pandas and NumPy for data processing. Once we have our data, we need to process and analyze it effectively. That's where Pandas and NumPy come in. NumPy is the foundation for numerical computing in Python. It allows fast operations on arrays and matrices. For example, You can quickly calculate averages, sums, or other statistics on large datasets. Then Pandas builds on NumPy and make it easier to handle tabular data. You can load data from CSV file or Excel clean. It merge datasets, transform columns, and perform analysis with just a few lines of code. Together, Pandas and NumPy make data processing fast, efficient, and polynomial. In short, Python is for automation and analysis, SQL for structured data handling, NoSQL which is MongoDB for unstructured data handling, and Pandas and NumPy for efficient data processing. Mastering these tools allows a data scientist or analyst to collect, process, and analyze data quickly, paving the way for insights, predictions, and informed decisions. Then, now let's move on to data visualization and business intelligence, which are critical for turning raw data into meaningful insights that decision makers can act on. So first one is a exploratory data analysis EDA with Matplotlib and Seaborn. Before we make decisions, we first need to understand the data. This is called the exploratory data analysis EDA. Matplotlib is a powerful Python library for creating basic visualization like line charts, bar charts, and scatter plots. It gives us control over every aspect of the chart, which is perfect when we need customized visuals. Then Seaborn built on top of Matplotlib is designed for statistical and attractive visualizations. It makes it easy to create heat maps, box plots, pair plots, and more. In real world companies, analysts use Matplotlib and Seaborn to explore trends in sales, customer behavior, or marketing campaigns. For example, a retail company might plot sales by month to identify seasonal trends or visualize customer segments to target marketing campaigns effectively. EDA, exploratory data analysis, is a critical because you can't fix what you don't understand. It helps identify outliers, missing values, and patterns in the data. Then second one is business dashboard with Power BI and Tableau. Once we understand the data, we need to share insights in a clear and interactive way. This is where business intelligent BI tools come in. Power BI and Tableau are industry leading BI tools used to create interactive dashboards. Dashboards allow stakeholders to monitor KPIs in a real time, filter data dynamically, and make data driven decisions. In practice, a logistic company may use a dashboard to track delivery times, shipment volumes, and delays across regions. A sales team may track product performance, revenue, and regional trends to adjust strategies quickly. These dashboards replace long reports with visual stories that are easy to understand and act upon. Then third one is a communication insights to stakeholders. Finally, data visualization is not just about charts, it's about communication. You need to tell a story with data, highlight trends, explain anomalies, and recommend actions. In companies, a data analyst or BI professional might present insights to management, marketing, or finance team to influence decisions. For example, our analysis shows a 20% drop in sales in region X due to low foot traffic. I recommend targeted promotions in this region. Visuals like heat maps, line charts, or bar graphs make your point clear instantly. So, in short, Matplotlib and Seaborn explore and visualize data for insights. Then Power BI and Tableau build interactive dashboards for decision makers and communication insights for make data actionable through storytelling. So data visualization and BI bridge the gap between data analysis and business impact. Companies that leverage these tools effectively can make faster, smarter decisions and gain competitive edge. Then now let's move to the machine learning which is at the heart of modern data driven decision making in companies. Machine learning allows organizations to predict outcomes, automate decisions and gain competitive advantage. First one is regression and classification models. Machine learning models are broadly divided into regression models used when the target variable is continuous, for example, predicting sales revenue, customer lifetime value, or stock prices. In companies, a retail company may use regression to forecast monthly sales based on marketing spend, seasonality, and past trends. Classification models used when the target variable is category. For example, predicting customer churn, yes or no, fraud detection, or loan approvals. In practice, banks use classification models to predict if a customer is likely to default on a loan, helping reduce financial risk. Then second one is a model evolution matrix. Once a model is built, we need to check how well it performs. Common metrics includes regression metrics, mean absolute error MAE, root mean square error RMSE, and R square score. Classification metrics accuracy, precision, recall, F1 score. Then, in companies, a marketing team might evaluate a model predicting companion success using precision and recall to avoid wasting resources on the wrong audience. Finance teams use RMSE to measure the accuracy of revenue predictions. Then, third one is business predictions. The ultimate goal of machine learning in companies is business predictions. Predicting sales trends, customer behavior, product demand, or equipment failure. These predictions enable proactive decision making, reduce cost, and improve efficiency. Examples in real companies. E-commerce platforms use ML to recommend products that a customer is likely to buy. Logistic companies predict delivery delays and optimize routes using ML models. Healthcare companies predict patient readmission risk for better care planning. Then fourth one is a advanced machine learning algorithm. XGBoost, extreme gradient boosting, and light GBM. Light gradient boosting machine modern companies often use powerful algorithms like XGBoost and light GBM for highly accurate predictions. Both are gradient boosting algorithms known for speed and performance on large datasets. XGBoost is a great for tabular data, handles missing values well, widely used in competitions. Light GBM faster than XGBoost on large datasets, efficient for real-time predictions. So, machine learning in a companies is not just about algorithm. It's about solving real business problems with data and driven tangible results. Now let's talk about deep learning and artificial intelligence. The cutting edge technologies transforming industries today. Deep learning is a subset of machine learning that allows computers to learn complex patterns from data, especially in images, text, and speech. So, first one is the image and text processing. Deep learning excels at handling unstructured data like images, videos, or text. Image processing. Companies use AI to detect objects' faces or detect in images. For example, e-commerce platforms use image recognition to tag product photos automatically. Healthcare companies use AI to detect tumors or abnormalities in medical scans. Text processing NLP, natural language processing, AI can understand and process human language. For example, chatbots for customer support, sentiment analysis for social media, or document summarization. Then second one is neural networks. At the core of deep learning are neural networks, algorithms inspired by the human brain. They are highly effective for pattern recognition, classification, and predictions. Examples in companies, banks use neural networks to detect fraudulent transactions. Streaming platforms like Netflix or YouTube use them for personalized content recommendations. Then TensorFlow and PyTorch to build AI and deep learning models. Professional use frameworks like TensorFlow, which is developed by Google, widely used for scalable machine learning and production systems. Then PyTorch, developed by Facebook, popular for research and experimentation due to its flexibility. In companies, TensorFlow powers AI-driven apps and predictive analytics platforms. PyTorch is used in R&D for self-driving cars, NLP, natural language processing projects, and computer vision research. Then fourth one is the AI-driven system. Deep learning enables intelligent systems that automate and enhance business processing. Autonomous vehicles. Self driving cars use neural networks to recognize roads, obstacles, and traffic signs. Smart assistants like Siri, Alexa, and Google Assistant use AI to understand and respond to user queries. Then, recommendation systems, e commerce, and media platforms suggest product or content based on AI predictions. Predictive maintenance, manufacturing companies use AI to predict machine failures, reducing downtime and cost. So, deep learning and AI are no longer futuristic. They are actively shaping business operations and customer experiences across industries. Companies that adopt these technologies can innovate faster, reduce cost, and gain a competitive edge. Then, next, let's discuss big data technologies, which allow companies to store, process, and analyze massive data sets that cannot be handled by traditional systems. First one is APAC Smart for large data. APAC Smart is a fast open source big data processing framework. It is designed to process large data set in memory, which make which makes it much faster than traditional disk-based processing systems. Spark supports batch processing, real-time streaming, machine learning, and graph processing all in one platform. Real world uses are e-commerce platforms like Amazon use Spark to analyze clickstream data in real time for personalized recommendations. And banks use Spark to detect fraud patterns across millions of transactions instantly. Then second one is a Hadoop ecosystem basics. Hadoop is the foundation of big data processing. It consists of HDFS, Hadoop Distributed File System, stores large datasets across multiple machines. MapReduce processes data in a distributed manner across the cluster. Then YAR manage resources across the Hadoop cluster. Hadoop allows companies to store and process petabytes of data effectively and cost effectively. Then real world uses. Telecom companies use Hadoop to store and analyze call records for network optimization. Retail chains analyze sales and inventory data across hundreds of stores using Hadoop clusters. Then third one is a distributed data processing. Both Spark and Hadoop rely on distributed data processing, which splits data which split data sets across multiple machines and processing them in parallel. This approach makes it possible to handle huge volume of data that a single computer cannot manage. So real world uses Netflix uses distributed processing to analyze user review patterns across millions of accounts. Airlines use it to predict flights delays by processing weather, proof, and traffic data simultaneously. Big data technologies are essential for companies that need to derive insights from large, complex datasets. They enable real time analytics, predictive modeling, and scalable data solutions, helping businesses make smarter, faster decisions. Then let's talk about cloud platforms which have become essential for modern business to store data, run applications, and scale analytics without heavy infrastructure investments. So first one includes AWS, Amazon Web Services, then Microsoft Azure and Google Cloud Platform. The three leading cloud platforms are AWS, Amazon Web Services, which offers a wide range of services including compute, storage, database, analytics, and AI. Then second one is a Microsoft Azure, integrates well with enterprises systems and provides cloud solutions for apps, data, and AI workloads. Then third one is a Google Cloud Platform GCP, known for big data, machine learning, and scalable analytic solutions. Real world examples. Netflix uses AWS to stream videos to millions of users globally. Banks use Azure to host secure financial applications and data pipelines. Healthcare companies use GCP for AI powered patient data analytics, scalable data storage. Second one is a scalable data storage. Cloud platform provides scalable storage solutions, object storage for unstructured data, relational databases and NoSQL databases hosted on cloud for structured data. Business can store petabytes of data without worrying about infrastructure and scale up down as needed. So real world uses are retailer retailers store sales, inventory and customer data on a cloud to access it anytime and anywhere. Social media platforms store user generated content like images and videos in cloud object storage for global access. Then machine learning workload and on cloud. Cloud platform allow running machine learning workloads at a scale. Services like AWS SageMaker, Azure ML, and GCP AI platform help train machine learning models on a large datasets, deploy models for real-time productions, monitor and maintain models effectively. So real-world uses are e-commerce companies train a recommendation system on cloud machine learning platforms to personalize shopping experiences. Logistic companies predict delivery times and optimize routes using cloud hosted ML models. So, cloud platforms empower companies to focus on innovation and insights rather than infrastructure management, making them essential for data driven AI enabled business operations. Then, finally, let's discuss deployment and MLOps, which take machine learning models from development to production, ensuring they are reliable, scalable, maintainable in real world business environments. So, ML APIs using Flask and Fast APIs. Once a model is trained, companies need to make it is accessible to applications or users. Flask and Fast API are lightweight Python frameworks used to build APIs around ML models. Flask simple and flexible for small to medium projects. Fast API fast, efficient and modern supports asynchronous request. So e-commerce sites deploy recommendation models as APIs so that product suggestions appear in a real time. Healthcare apps use APIs to provide disease prediction result instantly to doctors. Then second one is a Docker containerization. Docker allows you to package your ML model, code and dependencies into a container. Containers ensure that your application runs the same everywhere, whether on your laptop, cloud, or a server. So, companies like Spotify deploy ML machine learning services in Docker containers to scale recommendations engines globally. Finance firms use Docker to deploy fraud detection models consistently across multiple servers. And third one is a Git and GitHub collaboration. In modern teams, version control is a critical. Git, Git tracks changes in a code and GitHub allows teams to collaborate efficiently. Teams can manage multiple versions of models, share code, and maintain transparency production pipelines. So, data science teams in global corporations use GitHub to collaborate on feature engineering, model development, and deployment scripts without conflicts. And fourth one is production monitoring. Deploying a model is not enough. Companies need to monitor performance in production. Metrics like latency, accuracy, error rates, and drift detection are monitored to ensure the model continues to perform well. So, retail companies monitor recommendation models for changes in customer behavior, updating models when production start debugging. Banks monitors fraud detection models to catch evolving fraud patterns in real time. So MLOps bridges the gap between data science and production, enabling companies to scale AI solutions, reduce downtime, and maintain reliability in business operations. Now let's see how all these technologies we have discussed Python, SQL, machine learning, deep learning, big data, cloud, and ML ops are applied in real companies across different industries. So first one is a finance in fraud detection. In the finance industry, fraud is a major concern. Companies use machine learning models to detect unusual transaction in a real time. Then how it works? Historical transaction data is used to train classification models like XGBoost or GBM. Then the model learns patterns of legitimate or fraudulent transactions. In production, incoming transactions are scored and suspicious activity is flagged automatically. So, real world impact banks and payments gateways prevent millions in fraudulent transactions every year. Customer get alerts instantly, reduce financial risk. Then second one is a healthcare disease prediction. Healthcare companies use machine learning and deep learning models to predict diseases and assist doctors in diagnosis. How it works? Patient records, medical images, x-rays, MRIs, and lab results are analyzed. Models like neural networks detect anomalies or predict disease risk. So, real world impact AI predicts conditions like diabetes, cancer, or heart disease early. Hospitals can prioritize care, reduce errors, and save lives. Then, third one is a retail demand forecasting. Retailers use machine learning and big data analytics to forecast product demand and optimize inventory. How it works? Historical sales, sensibility, promotions, and external factors like holidays or weather are analyzed. Regression and time series models predict futures demand for each product. So companies like Amazon and Walmart avoid stock outs and overstocking, improving profitability. Personalized marketing campaigns are designed based on predicted demand. Then fourth one is a manufacturing quality prediction. In manufacturing, companies use ML and sensor data to predict product quality and prevent defects. How it works? Data from machines, sensors, and production lines is collected in real time. Models predict potential defects or machine failures before they happen. Real world impact automotive and electronics companies reduce defective productions and downtime. Productive maintenance saves millions in operational costs. So these examples show how data science, AI, big data, and cloud technologies are not just theoretical, they solve real businesses problems, improve efficiency, and create value across industries. Then let's understand the end-to-end workflow in data science. Actionable solution. This is how real companies turn data into decisions. First one is business problem identification. Every data project starts with a clear business problem or goal. The key is to define the objective, determine the impact, and identify the type of data needed. For example, finance. Reduce fraudulent transaction by detecting suspicious patterns. Retail. Retail. Forecast product demand to optimize inventory. Then healthcare. Predict patient risk for early intervention. Takeaway without a clear problem statement, even the best data won't deliver meaningful results. Then second one is a data collection. Once the problem is defined, the next step is to gather relevant data. Data can come from internal databases like SQL, ERP systems, then external sources of APIs, web scraping, then IoT sensors or logs for real-time monitoring. So real-world examples are e-commerce companies collect customers' purchase history, clickstream data, and product details to analyze buying patterns. Banks collect transaction logs, customer info, and account activity to detect fraud. Data cleaning and analysis. Raw data is often incomplete, inconsistent, or noisy. Cleaning is crucial. Steps includes are handling missing values and outliers, correcting inconsistent entries, transforming data into usable formats like numerical encoding, normalization, exploratory data analysis (EDA). Use Python libraries like Pandas, NumPy, Matplotlib, and Seaborn to understand patterns, correlations, and trends. Real world examples retailers clean sales and inventory data, then plot trends to identify seasonal spikes. Healthcare organizations analyze patient record to detect key factors influencing disease outcomes. Then fourth one is a model building. After understanding the data, the next step is to train machine learning or deep learning models. Steps include choosing the right algorithm, regression, classification, XGBoost, neural networks, then splitting data into training and test sets, training, tuning, and evaluating models using metrics like accuracy, RMSE, or F1 score. So, real world examples are banks build classification models to predict fraudulent transaction. Manufacturers build regression or classification models to predict product quality or machine failures. Then fifth one is a deployment and monitoring. Once a model is trained and validated, it's deployed to production for real world use. Deployment steps include creating APIs using Flask or Fast API, containerizing models with Docker, hosting on cloud platforms like AWS, Azure, and GCP. Monitoring performing in real time to detect drift or errors. Real world examples. Fraud detection models automatically flag suspicious transactions for review. Details demand forecasting models updates stock orders automatically. So deployment ensures that models deliver actionable insights and business value continuously. This workflow bridges the gap between data and decision. Companies that follow it efficiently can turn raw data into insights, predictions, and measurable business impact. So let's discuss career roadmap for anyone looking to build a successful career in data science, machine learning, and artificial intelligence. Companies today are looking for professionals who can collect, process, analyze, and deploy data-driven solutions. So learn Python and SQL. Python is the most widely used programming language in data science. It is used for automation of repetitive tasks, data analysis with libraries like Pandas and NumPy, machine learning models development with scikit-learn, TensorFlow, and PyTorch. SQL is essential for working with structured data stored in relational databases. So you will learn to query, filter, aggregate, and join tables, real world uses, retrieving customer or sales data, analyzing trends, and generating reports. So start by building small scripts and SQL queries on real datasets to gain hands-on experience. Then second one is build projects. Hands-on projects are crucial to showcase your skills. Projects demonstrate your ability to apply theoretical knowledge to real-world problem. For example, for beginner projects, sales analysis dashboard using Python and Excel, customer churn prediction model using ML, data cleaning and visualization project with Pandas and Matplotlib. Then third one is a learn machine learning and BI tools. Once you are comfortable with Python and SQL, learn machine learning algorithms and BI tools. Machine learning, regression, classification, decision trees, XGBoost, LightGBM, deep learning neural networks, CNNs for images, RNNs for text. Then BI and visualization tools like Tableau, Power BI, Matplotlib, Seaborn. Real world impact are ML helps companies predict customer behavior, detect fraud, and optimize operations. BI tools allows managers and stakeholders to make data-driven decisions using interactive dashboards. Then fourth one is cloud and deployment skills. As a company scale, cloud platforms and deployment skills become critical. Cloud platforms, AWS, Amazon Web Services, Microsoft Azure, Google Cloud Platform for data storage, analytics, and ML workloads. Deployment and MLOps. Build ML APIs using Flask or Fast APIs, containerize with Docker, version control using Git and GitHub, monitor models in production. So real world impact are cloud allows teams to train model on large data sets and serve productions in real time. Deployment ensures that AI solutions are accessible and reliable for business. Then fifth one is a bonus tips for career growth. Continuously learning and upskill AI and ML technologies evolve rapidly. Contribute to open source projects and Kaggle competitions to build credibility. Focus on domain expertise, finance, healthcare, retail, or manufacturing to add industry specific value. So, following this roadmap will prepare you to start as a data analyst or ML engineer and eventually grow into roles like data scientist or AI engineer, making you highly valuable in any industry. Then, as we wrap up today's session, let's summarize the keys takeaways. So, first, data science and AI solve real world business problems from fraud detection in a finance to demand forecasting in a retail. They enable intelligent decision making and power AI driven systems, helping companies stay competitive. Then, success requires end to end skills from data collection and analysis to model deployment and monitoring. Having strong fundamentals, hands on projects, and practical experience is what sets you apart. Developing industry ready skills, ensuring not just knowledge but a career that makes an impact. So, the journey in data science and AI is about applying knowledge to create solutions that matter. Focus on learning, building, and applying, and you will be ready to make a difference in any industry. So, thank you for joining today's webinar, and I wish you all the best on your data driven career journey.